now. So, yes, welcome to 9050. So, we'll have a chat today about just some of the kind of logisticy things relating to how we're going to deliver this course. And we'll also have some aspects relating to livability that we'll discuss. It should be a fairly easy lecture. So, let's kick off when I work out how to change the slide. Perfect. Um, so first of all, I would like to begin by acknowledging the traditional owners of the land on which UNSW Kensington campus is, because that's where I'm located today. And this is the land of the Bedigal peoples. So I'd like to show my respect to the elders past and present. And I think it's important that we did do an acknowledgement of country because this is related to the theme that we'll be talking about this semester. So some of you may or may not know that CVEN 9050 is a relatively new course. We ran it for the first time last year. In that year, we've kind of focused on the light rail, which is that new development at the Kensington campus. So we did some site visits and things like that. So obviously, the way that we'll be delivering the content this year will be very different due to the wonderful world that is our new COVID-19 reality. So we'll explain a little bit about why we're presenting the course the way we are. So this course was really developed as an alternative to a traditional research thesis. And so because it is an alternative, we'll still cover a lot of the skills that you would demonstrate and gain by doing the more traditional thesis, but we'll have more of a focus on getting you some professional skills that you can use in industry. So the types of projects that we'll be focusing on and the types of activities that we have were designed to have more of an industry focus rather than those who may want to go into academia. So this is part of the Masters of Engineering 8621 program. I had a quick look at all of your information not all of your information, but in your course enrollment information when I was having a look at the course list. So you're all enrolled in this program, so that's all fine. We run this in T1 and in T2 we have 9051, which is the next form of this course. So in this semester, it's more of a guided development of report writing and research skills, while in 9051, next semester, this will be much more independent research. So we'll give you all of the skills this semester, and then we kind of let you run free with all of this information. Obviously, we help you and guide you, but it's next semester is based much more about what you want to learn about and what you want to focus on. So who are we? Hi, I'm Dr. Ruth Fisher. I should have introduced myself first, apologies. I'm a lecturer in the School of Civil and Environmental Engineering. I'm an environmental engineer, originally a chemical engineer, but I've done various training and kind of switched more into the environmental field. So the areas that I'm really interested in are resource recovery and sustainability. And so some of you may or may not have done some courses that I've been involved with in the past, or maybe even indeed this semester. If you're doing 9898, I'm one of the lecturers delivering that. And so the topics that we're covering this year, because I got to play a big role in designing the course, I'm quite excited and I'm quite interested by a lot of the topics. So I hope you find them interesting too. Helping me deliver the course this year is Dr. James Hayes. He's a research associate and I've worked with him for many years. He's interested in psychology and olfactometry in engineering research. So a bit of a different take to some of the more, I suppose, traditional engineering focus. So he's interested in why we think the way we do and also olfactometry. Does anybody know what that means? If you do, quickly pop it in the chat. I'll wait for a little bit while I have a drink of my coffee. note takers? All right, so olfactometry is to deal with your sense of smell. So James and I have worked in the odor laboratory, which we have here on campus. So it's based in one of the basements below the civil engineering building. And in that, we look at measuring odors. And so this is a particularly area of interest for environmental engineers because nobody likes bad smells, but we like investigating what they're made of and why people don't like them. So anyway, a bit of a interesting facts about the two of us. So James will be helping in delivering some of the lecture content and also he'll be around in the workshops. We also have Mohammed Hadi, who will be one of our tutors and helping out in the workshops, and you'll get to meet him this afternoon in the workshop sessions. So what will you do? I've already covered this a little bit before, but in 9050, you'll conduct background research and you'll really be focusing on 3 prescribed themes. So in this, we're going to tell you exactly what you have to research, and you will do that and write up your findings. So you're using a combination of different primary and secondary data. So getting your own data, either by physically taking measurements or doing a literature review. And then we'll be also really focusing on presenting your findings. So looking at how to present an argument that's convincing, written work, verbal work, how to peer review other people's work. And then next semester, again, as we've already said, you'll be forming your own research question and then investigating that. So they lead on quite nicely from each other. So the theme for this year is livable and resilient neighbourhoods. So what this actually means and why did we choose it? So because we wanted you to really demonstrate the concepts that you're learning, we're going to be focusing on your local neighbourhood. So I imagine, definitely in my case, with COVID-19, we're all spending a lot more time in our houses. So with lockdowns and travel bubbles and locked borders, not being able to go on holidays or travel, maybe not allowed to go into the office, we've been spending a lot more time at home. And I know for what, in my case, I've been spending a lot more time wandering around the streets around my house. So this kind of got me thinking that we should really be paying more attention to our local neighborhoods in times like these. And so what I would like us all to do, we all live in different places and there's such a interesting situation. So I want all of us to kind of focus on our local neighborhoods, and this will be aided by some of the assessment tasks that we'll be doing. So as civil and environmental engineers, we really have an opportunity to shape and optimize cities, or indeed the local environments within those cities. So during this term, you're going to characterize your local neighborhood. You'll gather data relating to livability and suggest different aspects which could improve the livability and resilience in your local neighborhoods. By doing this, you'll produce some written reports, you'll participate in workshops, give video presentations, and take part in peer review activities. So the way that we would like you to learn is really by applying it and practicing it. So I really liked this quote. I think it very much sums up my teaching style. So tell me and I forget, teach me and I remember, but involve me and I learn. So throughout this course, we're going to first of all introduce concepts relating to research and professional practice. Then you'll discuss and practice these in your workshops with your peers. And then you'll be demonstrating these concepts in the assessments. And the way that we'll be learning, so we'll deliver some content, and this will be done through Moodle. You may have noticed that this is the only lecture that we're having. So the reason that we decided to go this way is with online learning, let's be honest, nobody really enjoys online lectures. So in the past, we've noticed that we get very poor turnout with online lectures. And I think there's a better way to deliver the information that suits the flexibility for students, especially if there's potentially accessibility issues such as poor internet, things dropping out. So what we'll be doing instead is having short little modules. So we'll have some videos that we'll record a few days before, and we'll also have some text and some resources that we'll upload each week. As well as this, we're really seeking your feedback. So if you have questions during the workshops or on the um, discussion forums, we'd really like you to give us those questions. And then if there's commonalities, we might make a few little videos and pop them up, or we'll have detailed answers to them on the forums. And we'll answer these throughout the week. And then the main focus for this semester is really the workshops. So each week you'll meet with your lecturers and demonstrators and your peers. Depending on what workshop session you're enrolled in, obviously it depends on where you are, um, we're having some different workshops. So you'll be either in person or online. And we do encourage you to attend the same workshop session all the time. We'll get into some logistics about workshops in a few slides. So everything for this course is held on Mondays. So that's easy. Monday will be 9050 day. So the week before, we'll upload the content that we want you to have covered for the workshops. So if you go onto Moodle now, you'll notice that the week 2 content is already up. So you'll be able to have a look at that. And I encourage you to have a go through that this week because we're not going to be giving you any homework, well, too much homework in the workshops today. So you'll be able to go through the content for week 2 this week, and then you will have prepared for the workshops next Monday. So in terms of workshops, as I said, there's 3 different sessions. So there's 2 in-person ones, and if you are around, we'd love you to come and join us. It was really nice. We've already had one so far, and it was really nice talking to people in the classroom. So we've tried to have really big classrooms, and so we can still enact social distancing. So that's good. And then if you don't want to come in, that's fine. I do encourage you to enroll in the online one. Obviously, if you're not in Australia, you can't come in person, which is unfortunate because we would love you to be here. But in that case, you definitely will be in the online session. And so that will be running through BB Ultra, as you already know, because that's the same as where we are now. Typically, though, the timing will be different. So at the moment, we are using the time slot that we have reserved for the online workshop. So the online workshop for tonight is fairly late at night. It's 6 to 8 p.m. in Australia. But in future, it will run from the 2 to 4 time slot where we are now. So the way that we'll run these workshops is interactive and discussion style. We'll encourage you to form into peer learning groups. So groups of 4 to 5 students who kind of just like make sure you stay together and learn from each other throughout the semester. All of the assessments are individual, so it's not group work, but we encourage you to still talk through problems and discuss what each of you are doing in your assignments so that as the way that I learn personally is I do like to discuss what actually is this assignment asking for. And so I want you to also do that with your peers. Obviously, you can ask us and the learning team as well. But I do think this peer learning is quite important. And also to kind of encourage discussion, we'll ask different people each week to answer questions. So we've got a list of people who are enrolled in each of the different workshops. And so we do really want to encourage you to have a chat We're not going to be recording any of the workshops because the way that we're presenting it, even if you listened back to the recordings, it wouldn't be particularly relevant. It's more the act of discussing and talking about your own research projects that are really important. So if you can't make the workshops in, I think it's week 7, there will be an assessment task running in the workshop. So you'll have to get special consideration if you can't get those. We do encourage you that if you can't, if you're going to be absent for more than one workshop, you discuss with us or get special consideration to miss that. If you are attending a face-to-face one and you're sick, totally fine. And isolating. If you're sick, you can get special consideration. If you're isolating, I'll have a sniffly nose and just don't want to come in because we're obviously not doing that with COVID, then I'll set up a video call so you can still be part of your allocated session. So if you do have any concerns or questions regarding this, just ask. So for those who are coming in on campus, in New South Wales at the moment, we're very lucky that things are currently fairly under control. So in order to keep that environment, we're making use of contact tracing. So in each of the classrooms, there are QR codes. So you'll need to register in with those whenever you walk into the classroom. There's hand sanitizer in the rooms, and I also bring it myself. If you have any symptoms, isolate and get tested. Tests happen in 6 hours now, so they're very quick. And if you were meant to attend a face-to-face session, let me know if you can't, and I can organise an alternative. We've tried to get really large classrooms, so we do have space for physical distancing. And as I said, there's hand sanitizers available. Use a face mask when you can't have physical distancing. Depending on the class sizes, we'll be using these if they're very busy classes. Obviously, if you would like to wear one, please do. We fully support that. And in order to get to the campus, face masks are mandatory on public transport. So you'll have them with you anyway if you're catching public transport. And if you want to know more information about the current status and how the uni's dealing with COVID-19, you can follow the link, this link here, and this will give you what's the current status for new NSW. So with the assessments, we're using ongoing assessment. So we've tried to space the assessments throughout the semester. So whilst you do have a fairly large assignment at the end, you have had an opportunity to still space it out over the semester. So with the way that these are styled, we're all working towards this engineering report. So by the end of the term, you'll have produced one final report, which you could use potentially to show in job applications, and it should be beautifully written. It'll be individual because it's all in relation to your own neighbourhood. And so when you couple this with your work next semester, you'll get definitely the equivalent of the more traditional research thesis stream. So in terms of due dates, you'll see that the first assignment is due in week 3. So we're hitting the ground running. We're starting very quickly, but this isn't a very large assignment, and I'll have a chat about that a bit later on. We also have a presentation. This is in the middle of semester, and then a peer review activity, and then the final engineering report. So in terms of these assessments, this initial case study identification is only 2 pages of writing. So it's not a whole heap of work, but we wanted it to be due early. So you can get something assessed, you can see how you're going. But more importantly, we can give you feedback as to the current status of your writing and communication. And then we can work on that during semester. And also it will let us identify if the case study that you've chosen and defined is appropriate for the rest of the work this semester. So we'll make sure that everything's working. We're not going to get to the end of semester and then we'll work out that something's wrong. Yes. Okay, so I won't read out these, but all of this information is in a document on Moodle. So it's called CVNO 9050 assessments. So all of the assessment information is in one file for everything. So you can check now what all of the expectations are for this semester. So what is expected of you? So we would like you to review all of the online lecture material in the preceding week. So by the time you get to your weekly workshops, we're all on the same page. We're not going to have a lecture style presentation in the workshops because um, it's kind of a waste of our time. We want to focus on this discussion and interaction with you. Um, we want you to participate in the weekly workshops. So they're not going to be recorded. They are going to be broken into small groups of students so you can discuss things amongst yourselves. We'll have tutors and the lecturers jumping through the groups either physically or online. And so we want you to show your opinions, practice communicating and all of those things, which can be a little bit intimidating, I know, but hopefully we'll make it not too scary. Obviously, you'll need to complete the assessment tasks, acknowledge and act on feedback. So we're going to try to give you a lot of feedback this semester as to how you can improve aspects or things that we thought were really good. So that's a key factor as to how we set up the assessments. And this one, because there are about 65 of you in the course, and it might be hard for us to keep track of exactly how each of you are going. If you are feeling stuck or there is an issue, do seek help early. So just send us an email and have a chat. It doesn't have to be, you can approach us individually, but we would like to know how you're going, and there's always solutions that we can come to. And so as you can see here, I do really encourage you to attend all of the workshops. This little star is here because it's okay if you don't attend one, but if you're going to be missing a fair few, we'll need to have a different solution. So yes, and obviously if it's face-to-face and you can't come in because you're sick or have symptoms, we have solutions for that. So you don't need to attend face-to-face if you're sick. Okay, and so each of the different courses that you do at UNSW has different specific learning outcomes. So I'm actually going to skip over this slide fairly quickly because James is going to go through some of these in a discussion in the workshop activities. However, if you want to have a read through in your own time, these are the things that are underlying the way that we're presenting the course, and these are the things that you're going to be able to do at the end of the course. Okay, so the next few slides, I've kind of got a justification as to why is it that you have to do this course. So one of the requirements for Engineers Australia for engineering courses is that students do a thesis in order to be accredited. So in Australia, you don't have to do a formal accreditation individually as to if you're, well, okay, let me preface that. In New South Wales, currently, we do not have to do a formal accreditation individually to call ourselves engineers. It's different in some of the other states. In Queensland, for example, they have brought in that you have to do an additional exam and pay fees and things like that through Engineers Australia. But in this case, at a university level, the university courses themselves have been checked over. And so that's why they can call themselves engineering degrees, is because each of the different courses does the same thing in a way. So everybody has to do a research thesis. So why? Why do they have to do research thesis? So first of all, let's start off with the definition. What is research? So research, simply put, is the creation of knowledge about the world around us, which makes sense. It has to be achieving something. So the thing that we're achieving is making knowledge. So first of all, in order to make a contribution to the world and to research, it needs to build on existing knowledge. So we need to know what came before us. The contribution also needs to be communicated, and it needs to be convincing, needs to be persuasive, and it also needs to be accepted. So these are the 4 reasons that we are kind of doing research and creating knowledge. And we'll get back to these 4 factors a bit later. So what is knowledge? So obviously there's many ways we can classify knowledge, but it's nice to break it down into three kind of states. So first of all, you can kind of look at what is an observation. So this is a snapshot or a thing that we observe. So it can be measurements from a lab or a survey. Um, they're not always interesting. It just kind of tells us what is the status, what is occurring, and it really needs to be interpreted. So, for example, an observation could be the particulates in air. So, what is the ppm of particulates, or the PM10, PM2.5? So, it's a thing that we can observe. We can measure it in the lab, but what does it mean? It doesn't necessarily mean anything, so it needs to be interpreted. So this is a form of data. So another form of knowledge, and here we're getting a little bit more complex, is a model. And a model represents something. It's a way to describe how something works. Usually it's a very simplified way to describe what goes on. So it has identified probably the main relationships in a very messy situation. So these kind of things can be, as engineers, we feel very comfortable with equations and formulae. However, another way to think about it could be a diagram or a map or written description. So obviously, it doesn't show exactly what's going on, but it shows a representation as to what is the important things that are occurring. So it focuses on the key factors and ignores the irrelevant to show relationships. And then the third type of knowledge is a recipe. And so this is a way of doing things or ordering things to achieve a certain result. So, for example, if you were to bake bread, it would be the series of steps to help accomplish things. So it would be the steps that you would take in order to bake bread. And so other examples of these could be like reference designs or software algorithms or processes or procedures. So they're steps of things in order to achieve a function or something, anything. And so all of these types of knowledge are important, and they can be used different ways. And I think when we're thinking about research, because research is creating knowledge, you can do all of these different things, but they will all kind of give you different values. So, for example, um, maybe as a type of research, you'd be looking at noise measurements in your local neighborhood. So, this would be an observation. Or maybe you could be predicting rainfall, or maybe what's a better one? You could be predicting runoff in your catchment of your neighborhood. So, this would be using a model. Or maybe you could be designing a new type of pavement curb. And this would be following a recipe because you could be using a standard design manual. So there are all these different things that you could do which are classified as research, but they're all quite different in terms of how they are set up. So I think when we're talking about research, it really helps to know what it is. It's quite broad in the scope. So why do engineers need to do research? So typically when you think about an engineer, what do you picture? Do you picture someone with a hard hat and steel cap boots, high vis, on a construction site? Or do you think about someone in a lab or someone using models on their computer, writing code? So there's a whole heap of different tasks that engineers do because engineering is very broad, but pretty much all engineers still need to do research. So some of the reasons, and obviously I haven't listed all of them here because there are so many more. Some of the reasons, so you might like to think of some, um, are we need to know what's already known. So what's the standard? What do people do in other countries? This is obviously important because you don't want to go out and propose something what you think is entirely new in order to find out that someone's already done that and they did it better and they did it cheaper. So it's sensible in order to know what's the current practice. Um, so you also want to know what's conventional versus what is state of the art. So what's standard practice and what is the best practice that you can do. If you want to be innovative, how can you be innovative? You need to understand the underlying systems in order to propose new ways to do things. Or if you want to improve the current things that you are doing, you need to understand how the models work in order to optimize them. Another important thing that engineers have to do is risk assessment. So you may have to research what are the current risks and what are some of the current mitigation factors. So there's a whole list of other reasons you can do research, and um, I won't get you to list them now, but maybe you'd like to jot some down yourself. And so you may or may not have heard of primary and secondary data, or indeed primary and secondary research. So primary research is kind of when you go out and get the data yourself. So it often is necessary to answer really specific research questions. So for example, if somebody, what's an example? Well, let's stay with our particulate example. If somebody wanted to know what was um, how many particulates did a coal-fired power station contribute in a specific neighborhood, then they'd have to go out and take measurements. Otherwise, how would you know? Typically, primary data, because you have to go out and get it yourself, it requires a budget and time. So it can be quite expensive and time consuming in order to get that data. Secondary data, on the other hand, is stuff that's been collected by other people. It's necessary to know what exists in order to understand what has already been conducted. And typically it's fairly cheap and quick. So you could find it from searching on the internet or contacting different companies who have done something similar, maybe contacting the EPA. And so if you were to use secondary data for your example of particulates from a coal-fired power station, you maybe could know what's the typical range of particulates, but you wouldn't know specifically what was at your power site. So still has value in order that you can understand the range, but it doesn't really help you answer your specific research question. So it's good to have a combination of both primary and secondary. So this is something for you to all think of separately, and I'm going to have a drink of my coffee while you do. But can you think of when you would use each of them in your career? So think about what you want to do as your career first, and then think about when you would either have to collect primary or secondary data. Okay, I hope you've had a think about it. Oh, good. Someone's talking to me. Yay. Hello. It could definitely depend on the scale of research. So typically, secondary data you would use if you only had a small amount of time, um, because it's much broader. You don't answer the same thing. If you're doing a lot of data, you'd want to use primary. Sorry, if you're doing a lot of research, you'd want to use primary data or primary research to get the primary data. So, um, yeah, you'd want to do everything. So, for example, if you were a geotech, you would need to do primary data because you'd need to go out there, take your core samples, understand what's actually in the soil. Um, However, as an initial step, maybe in order to, before you went on site, you'd look at some surveys and see what the typical soil type in that area would be. But here, you don't know for sure what it is on your site. So you can get a fair guess, but you can't get all the way. So you'd still need to do your primary analysis, depending on the project. So exactly, it depends on scale. So with this definition of research that we spoke about before, I've addressed some factors as to how we are going to help you prepare by knowing how to research. So, in order to make a contribution, it needs to build on existing knowledge. So, in these two courses, we're going to help you by practicing how to review literature. This can be various types of literature, grey literature, which is things like reports, um, or peer review, journal papers and things like that, which are the best form of data because they're peer reviewed. Maybe websites and textbooks, things like that. Um, your contribution also needs to be communicated. So here we're going to be practicing writing and presentations, and these are very important for you as professional engineers to be very fluent in how to communicate. It needs to be persuasive. And so not only do you have to communicate it, but you have to communicate it so that people believe you. So we're going to have sessions on how to present an argument, how to structure your writing so that it's clear that people know exactly what you're talking about. Um, Also, we need to show how to provide evidence. So how do you convince people that yes, this coal-fired power station is bad or good, depending on the measurements that you've taken? And also, it needs to be accepted. So here we're going to be covering aspects relating to how to critique, so how to evaluate different people's work, and also peer review. So in industry, you'll commonly be asked to have a look at somebody else's work or read this report written by a competitor, and you need to be able to read it, understand it, take a step back and look at the bigger picture. Is it correct? Is it convincing? Has it missed anything? Are there any big gaps? And so we'll be practicing these activities as well this semester. So I think we're getting to the end of these first introduction slides, and then we'll go over onto a new topic. So what's next today is I'm going to give a short chat about what actually is livability. So it's not generally a term that we as engineers are familiar with. And then in the workshop, we're going to be focusing on being a professional engineer. So talking about some of the Engineering Australia professional competencies. But before we finish this initial chat, I wanted to put up these slides because obviously last year was a bit challenging and this year still might be challenging. And so if you need any assistance this year about many factors, I wanted to put up this slide because it shows where you can go in the university to get help. You don't have to physically be here, obviously the internet, you can be anywhere, but if you need any help with financing, housing, or personal issues which are causing you stress or anxiety, there's a whole heap of services in the student support. And so I do encourage you to go just touch base if you're having any challenges. If you want to develop any academic skills, obviously we'll be covering a lot of them this course, but the university has a whole heap of support as well if you want to practice anything relating to writing or research or studying professional integrity. If you're having any challenges and need educational adjustments, if you have disability, medical or mental health conditions, talk to the Equitable Learning Services. They can do a lot and they're very lovely people. So their website's here. And also, if you need to have a chat with anybody about mental health or well-being, you can go and talk to the psychology and wellness team. So there's a lot of support. So I do encourage you to seek help if you need anybody to chat to or even just some advice. So we finished this initial slideshow. So we're not going to go for the first 2 hours, which I'm sure you'll be pleased about. So I might just push on unless anybody wants a break. Anybody in the chat? I only have 20 slides, so I'll continue and then we can finish a little bit early. So let me check that I'm sharing my screen again. All right. So this is one of my favorite images. So what this shows is how we could have a model representing a city. So this is the type of knowledge. It shows that a model is very much a simplification of the very, very complex system that is a city. So first of all, we have our inputs. So these are the things that are going into our city. So these could be things like food, water, construction materials, other products, energy, capital, information, and people. So these are flows that are going into our city. And then within the city, we've got different processes that are occurring. So we've got anthropogenic activities. Again, one of my favorite words, anthropogenic. This means the actions relating to human activities. So things such as things that we're doing as people, households, transporting things around, different industries and services. So, and then we have our urban stock. So these are kind of like the capital works, physical infrastructure. So things like housing, buildings, infrastructure, parks. And then we've got different products and services that are fulfilling the different anthropogenic activities. We've got some managed waste and emissions, which are linking in with both of these different factors. And then we've got some unmanaged, which are leaving our cities and going into the physical environment. And then as outputs from our city, we've got industrial products that we've produced. We've got services, so these could be banking or finance. We've got knowledge, a very big output from cities. We've got waste, and we've got emissions. So this is kind of how I like to think about cities. It kind of breaks it down into more of a engineering perspective. So the reason that I like defining it like this is because there's so many other ways that we can represent cities. So in Australia, and indeed in many countries, the majority of the population lives in urban centres. So in these urban centres, they use the majority of the resources and they produce the majority of the waste. So I suppose one of the areas that I'm really interested in my research, and depending on which subjects you do, if they're the ones that I'm helping running, you'll also have this similar theme. So how can we evaluate the performance of cities or areas where people live and work? So to start it off, I thought I'll just have a quick poll. So let me just set that up. Doo-doo. Oh, I can only have 5 questions. That's unfortunate. Okay, so I've just started a poll. Where are you right now? And unfortunately, I could only have 5 options. So I've had to group South and Central America, Europe and North America, large area together. So I'll wait a little bit longer and then I'll show you the responses. Oh, we're very even. So we're about half and half in Sydney and China. So that's good. Kind of similar to what I thought it would be. So even in Sydney, there's a whole heap of different ways that people live. And I imagine in China, it would be exactly the same. Different cities, different areas within the cities. So the next question I'd like to ask is, I'm going to stop that one. And, oh, is there a question? Oh, yeah, in case, I'm assuming everybody's, sorry, tangent. I'm assuming everybody's used Blackboard Ultra before. If you haven't, then if you do want to ask a question or say hello, you can use the chat or you can use the little raise hand function in the middle of the bottom of your screen. So I should have told you that at the start. Okay, so next question is, being typed in now. Okay, so where do you live? Do you live in a city? Is it a large city? I know that's a little bit difficult to compare within Australia and China because Australian cities are, let's be honest, pretty small. Um, but I'm interested to see if anybody's in a rural area. Ooh, 1. Very interesting. Which is okay, hopefully. I think I've still set up the questions that will still be flexible enough to compare. All right, so here you go. So we've got, as I suspected, we've got the majority living in large cities, some in medium cities, small cities, and some rural. That's good. That gives us a really nice distribution, and hopefully we can get some different interesting case studies going on. So I'll stop this one, and there will be 2 more. Okay. So this one's relating to personally, how do you live? Do you live in an apartment, a townhouse, or a little semi, a house, or a farm? Okay, so from the answers now, we've got the majority living in apartments. Very common in cities, not surprised. Live in an apartment myself. Some in houses, so that's good. It'll give us a nice, again, a nice mix. And two final questions. These ones will be yes or no, so they'll be easy. This is all anonymous. No one needs to know. Do you like where you live? Yes. Was there a question? Oh, you can't choose. Oh, that's weird. Wonder what I've done. Um, do do do. Oh well, if it doesn't work, we'll just skip that one. But this is something maybe you can think about to see if you like where you live. And then the final one will be also a yes no, so we won't do that in case it doesn't work. But have you heard of the term livability? So if you have, great. If you haven't, I'm about to tell you, so it doesn't really matter anyway. Um, yes. So thank you. That's good. I kind of get an idea of where you all live now. So when we're talking about cities, there's different ways we can kind of evaluate how they perform. So sustainability, everybody's heard of sustainability. It's particularly overused. So we'll cover a little bit about that. But the main area that I'd like to focus on, especially for this course, is livability. And so these are commonly used terms when planning or evaluating urban systems. So first of all, sustainability. There's a lot of different definitions for sustainability. However, this is the one that I really like personally. So, sustainability is the capacity for our human society to continue indefinitely within natural systems. So, I'm sure we've all seen the triple bottom line approach, where you've got environment, you've got economy, and you've got society. And so, obviously, that's all true. However, I think it could be repackaged in a different way. And so, the environment is the underlying area, and everything has to operate within the bounds of our natural environment. And then the society, and then the economy. So the economy has to operate within our society and within our environment. And things have to be able to be set up so that they operate indefinitely for it to be classified as sustainable. And if we're talking about sustainable infrastructure, this is infrastructure that is planned, designed, constructed, and operated in order to optimize these environmental, societal, and economic outcomes over the long term. So it makes sense. When we're talking about sustainable infrastructure and the sustainable development goals, hopefully you've all heard of the sustainable development goals. If not, they're a set of goals developed by the UN and the World Health and very many people all around the world. And so they're targets that identify areas we should be looking at in order to achieve sustainable development. And so it's quite important when we're thinking about our research to also look at what's the impact our research can have. How does it link in with these sustainable development goals? How can we use it to achieve these different aspects? And so there are all of these different areas. And this figure really shows that sustainable infrastructure has the ability to influence a whole heap of different areas relating to these sustainable development goals. And so the basis on which it can do that is either enhancing access to basic services or supporting inclusive growth or promoting environmental sustainability. So here we have these social, economic, and environmental aspects identified. But if we're then getting onto this term livability, how does this fit into the mix? So livability is when we think about the people who are using the cities. As engineers, the reason that we design things and we build things is really for people. So, and people live in cities, so therefore we should make sure that the cities are set up for people. So, livable cities are those that support the health, the well-being, and the quality of life for people who live and work in them. In order to be livable, typically they're safe, they're attractive, they have social cohesion and inclusivity, they have environmental sustainability, and they're affordable. They've got diverse different housing options, and it's all linked by public and active transport. So looks pretty nice, doesn't it? I'd love to live in something that was like this. And so these different aspects are included again in this figure. So it emphasizes the importance of these different aspects. So some of the things that we'll be looking at today is how to achieve livability and what is livability and how we as engineers can approach this probably fairly intangible concept that is livability. So in order to achieve it, livability, or another term could be better urban quality, it's really necessary to understand the different needs of diverse groups of people who may live in the cities and also how their needs may change. So as an engineer, we're very comfortable with the kind of the physical, tangible elements of a city. So things like what's the land used for? What's the built form? What are the buildings? We could look at the public spaces and the natural environment. What's the quality conservation? Are they well maintained? How efficient are our public transport networks? How accessible is the work, education, and health services? And also, what are some social and recreational opportunities? So these link in with the physical characteristics of cities. However, there's also, when we're talking about cities, other cultural aspects. And this is where there can be a great deal of variety between different cities, um, or even within cities, different neighborhoods. And so these are things like historical or contemporary ways of living, or the values or meaning attached to places, objects, activities, or events. Could be the application of technologies, and even the interaction with the natural environment in which cities are located. So, just depending on things like the climate or the history, it really dictates how people use cities. And because there's different ways in which people use cities, there should be differences in terms of the infrastructure that we provide the cities. So, here we're looking at rather than dictating their function in which people need to live, here we're looking at how people want to live and then using that to inform our infrastructure and engineering. So, why do we want to live in livable cities? Obviously, I think it's pretty clear why we want to live in livable cities. That would be quite nice. And so, in order to evaluate different cities, um, there's this global livability index that's been produced by The Economist, actually. And they have 5 different categories in which they've evaluated all of these cities around the world. So the first one is stability, and that includes things like prevalence of crime, threats of terror, and threat of military conflicts, healthcare, so how available public or private healthcare is, what's the culture and environment, so um, things like climate or level of corruption or even sporting that's available, education, so the availability of quality private education, infrastructure. Engineers, we love infrastructure. So things like the quality of the road networks and public transport, or the availability of good quality housing and the provision of water and energy. So does anybody know what the most livable city is? If you do, pop it in there. I don't think we can do a random answer poll, unfortunately. Austria, yes, it is in Austria. It's one of the cities in Austria. It is. Oh, wait there, let me. Melbourne's also up there. It is Vienna. So Vienna in Austria. Um, so I've been to Vienna many years ago when obviously we could travel. It was beautiful. It's very cold though, but Melbourne's also cold. So, and Sydney comes in at number 3, so that's very lovely for us. Um, so yeah, if you are interested in having a look, you can look at this Global Livability Index. Here are the top 10. Luckily, Australia does quite well. I think it's probably to do with our climate. But again, this is only a model. It doesn't represent the whole system. So as a city as a whole, we do quite well, but even in that city, in different neighborhoods, there's a lot of variation. So it's difficult to measure things like livability, but this is one commonly used method that people use. So when we're talking about measuring the performance, because livability is so intangible and broad, there's, and similar with sustainability, there's a lot of different methods that people use to have a look at these. So if we're looking at buildings, how do we evaluate the performance of buildings? This is quite commonly done. And so there's methods like Green Star or NABERS, which look at the performance of the buildings. For example, LEED also looks at the electricity. So there's a whole heap of these things. If we get a little bit more broader, and rather than buildings, we look at infrastructure. There's the ISCA sustainability tool, which is produced in Australia, or Sequel in the UK, or Envision in the US. And these are a little bit broader again, and they look at different aspects relating to the provision of infrastructure. So it's typically the construction, design, sometimes the operation as well. And then if we're going to look at regions, here is a method called One Planet Living. And this is one method where, again, they look at the performance. They break it down into different categories. And so depending on what you want to measure, there's a whole heap of different methods in order to try and quantify or develop frameworks in which you can evaluate these different descriptors. So again, these are some of the very many ways that you can try and represent the performance of a city. So you could look at quality of life for those living in the cities, or the global city livability. So this was the Economist Intelligence Unit Livability Index. That was that table that we saw before. Wellbeing, Happy Planet Index. So there's a whole heap of different methods you could use. You could look at safety. Do crime rates represent the livability in a city? It does one aspect, but it may not be the entire system. And so you'll kind of have a look at some of these different aspects relating to the first of your little mini chapters that you'll be investigating in the workshops. And so here, this is an example of the infrastructure rating system. If you do CVN 9898, you'll have another better look at these in more detail. But pretty much they can kind of represent a project into these different categories or themes and then categories. So looking at how a project relates to the use of energy and carbon or landscape and urban design. And here, in terms of what they actually measure, because you have to quantify something, it looks at how well your project performs or something. So um, in order, you have to achieve different levels. So by either using a material calculator in order to calculate how your project performs in material life cycle impacts, or maybe showing that you've actually achieved a reduction in the use of certain materials. So it's a way to be very broad, but also to represent the performance of different aspects. And here are some of the aspects relating to One Planet Living, which is one of the very many methods and where you can try and evaluate the sustainability and livability of different precincts. And so you can look at these different 10 factors. And again, this will be discussed more in week 3. So really, what I really wanted to get at is you have to be able to measure things in order to succeed. So if you wanted to improve something, first of all, you'd need to measure what the current situation is, and then how your thing that you do, how does it improve it? Because otherwise, how do you know? So this is another important aspect relating to research. You need to be able to quantify or describe um, what the current situation is and how you've made it better. And so another definition relating to what we'll be doing today, and again, this semester, is resilience. So the term resilience in general refers to the ability to recover from something. And so if you think about maybe somebody's health, if somebody isn't particularly resilient, they might be a little bit run down. If they get sick, they might not be able to get over it particularly well. However, on the other side, if they were very resilient, they would be quite healthy. If they got the same sickness that somebody else did, they would have the ability to recover from that much easier. And so if we apply the same principle in terms of a city, it's a city that has the ability to absorb, recover, and prepare for future shocks. And these shocks could be economic, environmental, social, or institutional. And so we really want resilient cities because they can promote sustainable development, well-being, and inclusive growth, and livability as well. So the types of pressures that may occur which could challenge the resilience of a city are either things like shocks, these are dramatic things that happen, things like climate, so hazardous events such as flooding, extreme heat or storms. Bushfires in Australia were some good examples last year, the flooding that's been happening even this year. Other things could be geopolitical shocks. There's been a lot happening in America lately. So it depends on how their cities are able to cope with this disruption. Geophysical shocks such as earthquakes or volcanoes, health shocks. I think we can all think of the prime example of how disease has the ability to impact the operation of cities. But also it could be socioeconomic shocks such as financial crises or political disputes. And then rather than these shock types of pressures, we could also have chronic pressures. And so these are things where there could be shortages of basic needs, um, or economic problems and inequality, socioeconomic problems such as crime or lack of health care, education or housing, or even infrastructure problems. So these are things that us as engineers, we need to really make sure that we have our infrastructure being obviously operating, but also being resilient so that it can withstand other things here, but also it doesn't cause other problems if it isn't operating properly. So if we want to measure city resilience, we could look at different aspects as well. So if we wanted to look at the economy, we could look at GDP, unemployment, or maybe aspects relating to how many people are working and who are they who are working or unemployed. Again, in terms of society, governance, and environment, there are different indicators that we can use when we're looking at how well these systems are working. Linking in with sustainability, the climatic risks is one of the biggest threats to resilient cities. So this overall chronic can cause these different shocks relating to flooding, heat waves, fire, and snowfalls. Probably not a problem in Australia, but particularly in different areas in China, I imagine that could be quite debilitating. And storms. So in order to be more resilient, there's obviously physical ways that we can build our cities, as well as soft systems. So the physical things could be building seawalls or raising river embankments, creating artificial floodplains, raising housing, or diversifying systems. So these are things that us as engineers can think about when we're designing our systems in cities. However, there's also these soft methods, so such as developing neighbourhood systems to check on vulnerable people during times of a crisis, or preparing adequate evacuation procedures. In Australia, I think these soft systems have been definitely worked the last year. So during the coronavirus, there was our local council in Randwick put out a mailbox campaign where they put little letters into people's mailboxes of saying, "Are you okay?" And they had a number and they were like, "Check on your neighbor," just like encouraging people to kind of show a sense of community and to try and develop these soft resilient systems in order to make sure that people were okay if they couldn't go out and get the milk because they were isolating. And then in terms of the bushfires that also occurred last year in Sydney, having good systems operating so that people would know when where they had to get information from, where they could evacuate to, and when they had to evacuate. Because if you leave it too late to evacuate, you have to stay in your house because otherwise it's too dangerous to evacuate in a bushfire. So that's why it's very important to have these procedures already worked out. And if they are, then you have a more resilient system overall. So we'll have more of a chat about this in week 5. So this is, I think this is the last slide. So it is. So what I would like you to think about is think about your immediate neighborhood. What's to you, what is good, bad, unique, interesting about it? Think about how engineers can affect it, the physical systems probably. Think about how you could measure the performance. So how can you make it more livable? Means that you need to have different aspects relating to what is livability. And relating to that, what do you feel is important for livability in your area? So we'll be focusing on these types of aspects in the next few weeks. So I'd really encourage you to do a bit of searching, soul searching about how this relates to you. And also, as we go through the semester, you might think of some interesting research questions that you may want to investigate more next semester. So I've set up a research question database on Moodle. So if you do have any ideas, pop them down in this research question database. I'll be putting some in as well as I think about them. And then this could be a good database that people could refer to next semester, because I think one of the biggest challenges last year were people were having a difficult time defining their research question. So start thinking about early what you'd like to research. So that's that's the end of the session for today. We will be seeing you in the workshops. So we have a face-to-face one next, and then a online session at 6. So tune in and we'll be breaking you into little breakout groups and having some discussion questions. And if you have any questions for us, you can use the forum or ask us during these sessions. So stay on the line if you want to chat about anything. I'll turn off the recording, But otherwise, I'll see you in the workshop sessions. Thank you.